La da dee, la da da, la da 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 da, la da dee, la da da. This is lesson 3.2. Work with exponents. We are working with exponents this lesson and next lesson. If you flip the page to page 10, you'll see the rules for exponents, so exponent laws. We're going to be discovering those, but for now we're just going to talk about, well, what is an exponent? What does it represent? What does it do? And you have a chart there at the top, and the instructions are to complete the table in order to record the number of new customers as a power. So you're a shop owner, and you're getting new customers every day. And on day 1, you get 2 new customers. And in expanded form, that's just 2. And as a power, that's 2 to the power of 1, because you have one factor of 2. It's just 2. It's just happening one day. But on the next day, day 2, you get 4 new customers. Now we know that we can represent 4 as 2 times 2. In this case, we have 2 factors of 2. In exponent form, that's 2 to the power of 2. Go ahead and fill out the rest of the chart. Take your time. It's not necessarily supposed to be easy. See if you can come up with the power for each of the expanded forms. All right, hopefully you tried this on your own.
I was way off. 64.
I got the right power and everything, not just the right number.
Slow down, slow down, slow down. Okay. We skipped a bunch of numbers in here. Basically, all you're doing is adding, in each new one, you're adding another factor of 2, which would mean the next one, if you, on day 5, you would have had 5 factors of 2, right? Don't write this in, you don't need to. On day 6, you would have had 6 factors of 2. On day 7, you would have had 7 factors of 2. And in order to write that in expanded form, you need 8 factors. On the 8th day, you need 8 factors of 2. 2 times 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 2. And you'd probably use a calculator for this, but you don't have a calculator right now, so you're doing it in your head, which is fine. But 2, you just double it every time, right? 2, 4, 8, 16, 32, 64, 128, 256.
How can you just do that?
Okay, the rest of your page there is going to be used to take some notes. Don't use up the whole page with what I'm giving you now. Actually, you pretty much can use the rest of the page to do what I'm giving you now. So here we're going to write a power is a product. You guys know what the word product means? It's the answer to a multiplication question, right?
Definition.
So a power, yep, is a product of identical factors period. It consists of 2 parts. So a power consists of 2 parts. We have, for the example, you can draw this fairly large. You're going to have 2 to the power of 4. Where 2 is called the base. And the 4 is called the exponent. Okay, so every power has 2 parts. It has a base and it has an exponent. The base is the identical factor. The base is the identical factor. That means it's the factor that gets repeated. The exponent tells how many factors there are. So if we took this 2 to the power of 4 and we expanded it, we would end up with 2 multiplied by itself 4 times. 2 times 2 times 2 times 2. Instead of writing all of this, we can just write 2 to the power of 4. All right, let's take on example 1. In example 1, we have a whole bunch of, actually 6 different problems to do, and it's just evaluating powers. So we're going to be given a problem as a power and have to determine its actual value by first writing it in expanded form. So in A, we're given 2 to the power of 5.
Where are we?
Example 1, top of page 9. Yeah, the example isn't there for you, so you actually have to write it in this time. I know that's tricky. So you're given 2 to the power of 5. Well, in expanded form, what's the base and what's the exponent? 2 is the base, 5 is the exponent. So 2 is our repeated factor, and 5 is how many factors there are. So we have 2 times 2 times 2 times 2 times 2. We have 2 multiplied by itself 5 times. And now we need to evaluate that. Well, exponents of 2 are pretty straightforward. You're just doubling it each time. So we've got 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Another way to do this would be thinking about it in groups. For instance, if you know that 2 times 2 is 4, you could say, okay, now I have 4 times 4 times 2. 4 times 4 is 16, times 2, 32. Or if you know 2 to the power of 3 is 8, 2 times 2 times 2 is 8, you could just do 8 times 4 is 32. So you can think about it a few different ways. B. B adds a little trick in it. We're going to take the base is a negative number. So we need to write this in expanded form, which, because multiplication is default operation, we can just rewrite it like this. We have negative 3 times negative 3 times negative 3. And now we just apply our rules for multiplying integers, which tell us that if we have, who can explain if this is going to be positive or negative? It's going to be negative. How do you know?
Because there's
Odd number of
If
it was squared, it would be positive.
Good, so there's a few different ways that I just heard you describe it. First is there's an odd number of negative factors, which means it's going to be negative in our answer. The other one is, negative times a negative, that's a positive, times another negative, negative. So we've got negative sign, but what's our numeric value going to be? 27, right? It's 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, so we have negative 20. Sorry, oh boy. Yep, you're right. I was looking at the next one. The next one is similar to that one. We're going to run into the same issue with negative 3, but this time we're raising it to the power of 4. So go ahead and write that in expanded form. Determine whether it's positive or negative, not out loud. And then determine what the numeric value is. Now you might not want to multiply 27 times 3. So how could you think of this?
9 times 9.
9,
81.
9. Positive 81, okay? Good. A, B, C, D. Now, this one is important to pay attention to, because now we have negative 3 to the power of 4. And you might say, oh, that's exactly the same as C. But it's not, because the base of this power is what? Just 3. And the exponent is 4. So we're actually doing 3 to the power of 4. And the answer is for sure going to be negative. Remember, it's just like bed mass.
It's negative
How would you know if it's written in a normal question?
Exactly what we're talking about now. If it's written like this, then the whole base
then it's
is
together.
negative 3, and it's together, because brackets comes before exponents. So these guys belong together.
So could you
But
check
down
if we just
here-
put 3/4 in brackets? Outside with the negative? The negative outside?
You're asking, could this be written like this?
Yeah.
Yes, it could. It doesn't need to be. Okay? This, once we know all our rules and we're paying attention to bedmass, this can't be mixed up as that. Okay? This will never, ever, ever be the same as that. Never. And this will never be the same as this. Okay? They are different things. This has a base of -3 and 4 factors of -3. This has a base of 3, 4 factors of 3, and then a negative sign out front. So this is what this one looks like. If we expand it, that negative sign stays out in front, and then I'm going to use brackets to express our power in expanded form. 3 times 3 times 3 times 3. That shows us that we still have a numeric value of 81, 9 times 9, and it's going to be -81. Okay? So again, all it is reflecting on bedmass. In number C, brackets come before exponents, so -3 is the base that gets repeated, ends up being positive. In D, there are no brackets, so we go to the exponent. Well, the exponent says I have a base of 3 and an exponent of 4, and subtraction is way down here at the bottom. So that's not going to interfere with our expansion of our power, but it is going to stay out in front and give us a final answer of -81. 2 more.
Are we going how to do with the exponents if it's a negative exponent?
Yes. Maybe not this year. I'm not sure, actually. That's a good question. There are negative exponents, though, yeah. Yep.
Good thing.
And there's a pattern that actually makes them not that hard, and a rule that makes them pretty straightforward. You can also take a power of a base that has a decimal, so a rational base. This is in decimal form, not super difficult to put in expanded form. 3.5 times 3.5 times 3.5. You could also write this, by the way, you don't need to write it this way, but you could also do it this way if you like that better. Makes no difference to me. Okay? And this one you would put in your calculator. I'll just give you the answer, but basically on your calculator you would write, you would press the button 3, you would press the button decimal, you would press the button 5.
No.
Then you would press the button, your button might look like this. Y to the power of x means you're doing an exponent, and then you would hit the button 3, and then you would hit the button equals.
Wait,
So you should have your calculator out.
Wait, I have x to the power of 2 and x to the power of -1.
So neither of those are what you're looking for. Or it might be a caret or something like that.
Yep.
You might have a caret button. Okay, there's a couple options there.
Yo, I feel like a
Oh, I have a caret button.
And you guys can give us the answer then. And everyone else,
2.87?
the final answer should be 42.875.
Yes.
Okay, if you have a calculator, you should be getting it out so that you're doing these things and learning them as we go. The last one, F, is also a rational number, but this time it is in fraction form, 2/3 to the power of 3. Now it might not be immediately obvious what to do here, which is why we're asked to put it in expanded form first. So go ahead and put it in expanded form. 2/3 is the base. 2/3 is the base. 3 is the exponent. So you have the repeated factor of 2/3, and you have it repeated 3 times. So we have 2/3 times 2/3 times 2/3. Nothing is different. Okay, just because it's a fraction doesn't make any sweet difference how you record it in expanded form. It's the base repeated 3 times. Now, how do we multiply fractions?
2 times 2 times 2.
8.
Top times top times top, bottom times bottom times bottom. So I'm going to rewrite this way so it's easier for us to see. In the numerator, we have 2 times 2 times 2. In the denominator, we have 3 times 3 times 3.
8/2.
In the numerator, we have 8. In the denominator, we have 27. Okay? If you have a little bit of extra space, you could even write this guy, and we'll learn this as we go. But this can also be written, look at this. 8 is 2 cubed, and 27 is 3 cubed, right? This is 2 to the power of 3 over 3 to the power of 3. So look what it's the same as.
Wait,
Okay?
that could be your answer?
No, this is the value. This is another way to write it. Example 2. So now we're applying our exponent skills and our algebra skills to a word problem. There you have 2 containers. Okay, you have a cube and a cylinder, and we're asked which one holds more popcorn. Now you are missing some information. One of the most important pieces of information that you're missing on the cube is the word popcorn.
Oh, seriously?
Oh yeah.
Seriously?
And on the cylinder, you guessed it, popcorn.
We don't know what we're talking about then.
Okay.
What are they?
The dimensions, so this guy is a perfect cube, okay, the popcorn box. The dimensions are 9.2 centimeters. This dimension is 9.2 centimeters, and this dimension is 9.2 centimeters. Length times width times height, all of them are 9.2. For the cylinder, he has a radius of 10.4 centimeters and a height of 9.0 centimeters. This guy is called the mega box.
A radius or a diameter?
Oh, sorry, yep, diameter. Good call, good catch.
I forgot what it is.
Mega box, and this is called the jumbo drum.
Did you just make those up or is that?
No, I did not make those up. And we need to determine which container is going to hold more popcorn. What should we do? By the way, they're just filling them
Find the
flat to
volume.
the top. Find the volume of each cylinder.
Length times width.
Okay? Now, do you know the volume of a cube?
Length times height times height.
Length times width times height. So we've got 9.2. Oh, but
Square,
hold on,
square,
hold on,
square,
hold on,
cube,
hold on. Let's not skip everything we've learned already.
Cube.
So instead of doing length times width times height, we'll do the side length cubed.
Yeah,
Oh,
just do that, guys.
What? No.
If you didn't know.
So we've got 9.2
yeah.
cubed.
No, we didn't.
That kind of looks like 5 though.
So it's 7.
And now all you have to do is put that in your calculator.
778.688.
Is
You're good.
778.688.
Thank you very much.
I did not.
And that is measured in centimeters cubed.
Because it's a cube.
And let's go over to the jumbo drum. Anyone know the volume of a cylinder?
Isn't it?
Is it pi
Or pi,
times
yeah.
diameter
Pi times
No.
times
3.1.
radius
Yes.
or height? I don't know.
So
Oh, that was right for
it's the
this.
area of the circular face times the height. So the area of the circular face is pi r squared times the height. We are given the diameter, so what do we need to do to that 10.4?
Divided by 2.
So we've got pi times 5.2 squared times the height, which is 9.0. This is where brackets are just cleaner than those multiplication symbols. You can plug that whole thing into your calculator
764.
in one go. And we're estimating this one. This one we're going to be rounding down. So whenever you're getting an approximate answer, you put a little dot above your equal sign to show that it's not the exact answer because it's an irrational number.
764.1504.
764.45, good enough.
4, 5.
5, no, 5. 0.
5.4, sorry.
1, 5.
No, it's 150 for the decimal.
Yeah?
Yeah, it's 1.
You all got that?
Yeah,
Yeah, 150.
Yeah.
It's 150.
We're going to do it.
Okay. Then the book is wrong, which is okay. And this is centimeters cubed. So, if you were at the popcorn stand at the theater, what is the better choice for you?
Square.
Mega box.
A mega box.
Maybe not. What if you want less?
Well, they're asking what do you.
Yeah, pretty stupid,
Why
Sam.
would you want
Yeah.
less popcorn?
Because what if Jake's
What
on
if
a
you run
diet
out?
again?
What if you run out menu?
Yeah.
Like, what if you take Jake? Like,
So we're answering the first question, saying the mega box holds more popcorn, always finishing with a full sentence. And then the second part of the question asks us to find out how much more. So what are we going to do here?
Subtraction.
We're going to simply take the amount that's in the mega box, which is approximately 779. That's good enough. And
Shove everything up.
we're going to take away the amount that's in the jumbo box, which is 764, and that's going to it holds 15 centimeters cubed more popcorn. Your practice problems for this lesson are at the bottom. They come from page 19 in your textbook, number 1 through 44, 61, and 62. Please come to our next class with questions.